Hi, in this video, we will discuss how to perform the Laplace transform using the property 6, which is the shifting property of the delta function. This is the formula for the delta function, where delta function is an impulse function, or it also called the direct delta function. The direct delta function means that you have a high magnitude force acting on a very short period of time. For example, like you have a hammer struck on a nail, or a golfer struck a golf ball. Besides call it to be the impulse function or direct delta function, some books also call it as unit impulse function or unit impact function or simply delta function. This is the definition for delta t minus a. It means when your t is equal to a, your delta is equal to 1, and when your t is not equal to a, then your delta is equal to 0. For example, if your a is equal to 5, then at t equal to 5 here, you will have one unique impulse function like this, where you have the magnitude equal to 1. So the magnitude here indicates the area instead of the magnitude of the height. If you zoom in this curve, you will obtain this graph, where you can see that at t equal to a, let's say at t equal to 5 here, so your a replaced with 5. So you have the duration to be very small, where your 5 plus k here, your k is very close to 0. So for example, plus k to be 0.0000001, which is very small number. So your height is in the function of 1 over k. When your k is close to 0, so 1 over k will be close to infinity as well. So in fact, your height is infinity height. When you multiply 1 over k with the width, which is the k here, then you get the answer to be 1, which is the area for this curve. So with that, we know that when we integrate the delta function with respect to time, we are actually calculating the area for delta function. So since the delta function has the area equal to 1, therefore you obtain 1 in this case. Unit impulse function is very important due to the shifting property. So shifting property here means that it provides a method of isolating or shifting out the value of continuous function at any particular point. For example, you have a continuous function 2 cos t, which is this function in blue color, and you have an impulse function at delta t minus 3. So at t equal to 3 here, you have an impulse function. How can we use the impulse function to shift out value at any point of the cos t function here? So if you multiply it with the cos function, you will find that 1 here multiplied with -2, the magnitude here will be remain. And the other part you will get 0 because you have 0 multiplied with the 2 cos t function. Therefore, when we multiply any function with the delta function here, you will obtain a shift out result like this, where the impulse function at t equal to 3 here will shift out the value at t equal to 3. So you can see that when you take the integration, okay, for this curve, the total area will be only here. The other part will be 0. So we can check that. Okay, you have 2 cos t multiplied with delta t minus 3. So you shift out the value for 2 cos t at 3 only. Therefore, the value is close to -2. If you shift the impulse function, let's say at t equal to 5 here, so you change the a to be 5. Therefore, when you multiply, you will find that your t, okay, you shift out the cos value at t equal to 5. 2 cos 5 is equal to around 0.56 here. So you can see, okay, the magnitude from the graph. So in general, the shifting property of the impulse function can be represented by this formula, where let's say we have any function ft, when you take it multiply with the delta function here and integrate it with respect to the dt, then you will shift out the value for ft function at t equal to a. So this is the shifting property. So when we apply in the Laplace transform for delta t minus a, by using the definition, your ft will be equal to delta t minus a multiplied with exponential negative xt. So the delta function here will shift out this function at t equal to a. So therefore, you obtain this result. And when t is equal to this, where your a is equal to 0, so you can substitute the a equal to 0 here, exponential negative 0, you obtain 1. So therefore, if you take the Laplace transform for delta, you will get 1. Let's solve this ODE, where you have the right hand side, which is the forcing function equal to 4 delta function. The initial condition y0 is equal to 1 and y prime 0 is equal to 0. So first step, we need to perform Laplace transform on both sides. So Laplace transform for 4 delta t minus 2 pi, we can refer to this formula. So when you take the Laplace transform for delta t minus 2 pi, so your constant can be taken out, 4 here, is equal to 4 multiplied with exponential negative ax. So your a is 2 pi, therefore you have 2 pi x. So this is the answer. And then taking the Laplace transform for double prime, you have x squared minus x minus y prime, and then capital Yx. So y0, y prime 0. So you can substitute y0 to be 1, y prime 0 to be 0, so this term cancels. Lastly, y Laplace transform, you obtain capital Yx. Collect the term for Yx, you obtain this. You have x squared plus 1 here, and then this one is negative x. Then extract your Yx on the left hand side, then you should be able to obtain this term. And you separate it into two parts. One is for the exponential part, another one is x over x squared plus 1 part. To obtain the yt, you need to perform the inverse Laplace transform. So this term is much more easy, where we can have the cos t function, because you have x over x squared plus 1, where in general you'll be in this format. So your omega is equal to 1 in this case. Therefore, you have cos omega t, where your omega is equal to 1. Then you see this term, okay, to take the inverse Laplace transform, you see there is an exponential function. That means you have the time shift. This is the time shift property formula. When you take the inverse Laplace transform for exponential negative ax fx, then you will obtain the ft minus a ut minus a. So when we compare to this term, so you will obtain the a to be this, which is 2 pi. And then your fx will be the remaining term here, so equal to this. So from the fx, if you want to find your ft, so if we just for, so this x squared plus 1, with that you know is a sine t function, because the omega square is equal to 1. So if you look at this function, you need the ft minus a, where you know your a is 2 pi, therefore you need to find ft minus 2 pi. So you substitute t equal to t minus 2 pi inside this formula, you obtain 4 sine t minus 2 pi. How about ut minus a? So ut minus a is just ut minus 2 pi. So your final answer here will be 4 sine t minus 2 pi multiplied with ut minus 2 pi, which is this answer. So with that, you success to obtain your yt. So you should know how to read this. So cos t is valid for all the t. Therefore, at t from 0 to 2 pi, you also have cos t there. But for this term, it's only valid for t greater than 2 pi. T less than 2 pi, this term will be equal to 0. Therefore, you only see this term in t greater and equal to 2 pi. So by using this, you can plot the graph. When you plot it, so from 0 to 2 pi, then you get cos t, which is in blue color. For t greater and equal to 2 pi, you have 4 sin t plus cos t, which is in red color.